I keep telling you that there's no cloud and that it's just someone else's server. I also keep telling you to build things. DNS filtering, a camera NVR, a Nextcloud box, a voice assistant. All these things live in your house, on your server. Since the main appeal of the cloud is that you can access data or services anywhere, the obvious question is, how do I access my stuff when I'm away from home? The old answers were all bad in their own special ways. You could port forward, poking holes in your router's firewall so devices outside your LAN can reach resources in your LAN. That works. It also means your NVR's login page is now visible to every scanner bot on Earth. They are literally search engines like Shodan that catalog exposed devices so that bad guys don't even have to do their own scanning. Hard pass. You could use the vendor's cloud relay, the Reolink UID and P2P thing that I told you to turn off in the NVR video. Remember why? It's because your video can flow through their servers on AWS. Say it with me, someone else's server. Or you could roll your own VPN with OpenVPN or plain WireGuard. It's a valid answer, but be prepared to become the family's unpaid on-call network engineer. I'll come back to this one later in the video. Unsurprisingly, I covered a better solution in a video a while back on Pi-hole and AdGuard Home, but it occurred to me that I can't really count on you all to be watching the entire back catalog. So when I put out a self-hosted NVR video the other day, I figured it was time for a video on Tailscale. Tailscale is what I actually use on this channel and in my own house. Welcome back to Dad Explains Everything. Today, you'll learn what Tailscale is, how it works, what the alternatives are, and why I think it's an important part of every project I've shown you. Then we get to the most versatile trick in the whole Tailscale toolbox, the subnet router. I'll even show you how to build one two different ways, on a Raspberry Pi or basically any other Linux machine, and on a Windows PC. Like with many of these videos, there's a worksheet for this one too. The worksheet link is in the description below. So let's start with what Tailscale actually is. Tailscale is a mesh VPN. Now, I know VPN makes most people think of sponsor reads, protect yourself on public Wi-Fi, watch in other countries' Netflix. Yeah, I have a video linked in the corner giving you my take on those VPN providers. That is not this. Those commercial VPNs route your traffic through their servers, and one more time, that's still someone else's server. Tailscale is another kind of VPN. It's a network overlay which creates a private network between your own devices. Your phone, your laptop, your Proxmox server, your Raspberry Pi, all connected to each other over encrypted tunnels, no matter where they physically are. You can even put your friends and family on the same private network and access each other's network resources transparently. It's immensely cool, and it's a lot more versatile than just setting up a VPN server that you host at your own home. Your phone on hotel Wi-Fi in Orlando and the Pi in your basement behave like they're on the same LAN. Tailscale calls this network of yours a tailnet. Under the hood, Tailscale is built on WireGuard, which is the current gold standard for encrypted tunnels. It's fast, it's lean, and the code is small enough that security researchers have actually been able to audit all of it. WireGuard does the encryption. What Tailscale adds is everything that makes WireGuard livable for normal humans. Here's how it works. You install Tailscale on a device and log in. The device generates its own encryption keys and registers with Tailscale's coordination server. Think of the coordination server as a repository of machines in the tailnet, and it acts as the connection broker for the clients on the tailnet as well. The actual traffic, your camera footage, your files, that flows directly between the devices, end-to-end encrypted, and Tailscale, the company, can't read it. The company only handles the repository. It never handles the data. Every device gets a stable private IP address that starts with 100.something.something.something, and that address follows the device everywhere. Hotel, home, cellular, it doesn't matter. With Magic DNS, you also get names so you can reach Basement Pi instead of memorizing numbers. And here's the part that's super convenient: NAT traversal. Tailscale can connect two devices even when both of them are behind routers, without you opening a single port. Punches through, even through CGNAT, which tons of ISPs now use, like T-Mobile Home Internet and Starlink. This is important because you literally cannot port forward on those connections. And in the rare case where a direct tunnel can't be established, Tailscale falls back to bouncing your traffic off of a relay server. But that traffic is still end-to-end encrypted, so even the relay can't read it. As a bonus, you don't need to set up dynamic DNS. What does all this cost? For personal use, nothing. The free plan covers up to 3 users and 100 devices. That is a lot of house. Because Tailscale isn't the only game in town, I'll mention some of the other options. There's a VPN server like WireGuard or OpenVPN, self-hosted. This runs on a Pi or many routers. It's completely yours, completely free, zero third parties, but you manage the keys, the configs, and every new device by hand. Plus, you need an open port. Unless your ISP blessed you with a static IP, you'll also need a dynamic DNS setup. It's the manual transmission of remote access. I hosted my own home VPN for a decade and a half, but I no longer do. Most people don't want it, and plenty of people can't host a VPN even if they wanted to. ZeroTier is another big name in this space, and it's been around longer than Tailscale. Same idea, a private overlay network with its own protocol instead of WireGuard. There's a free tier, it's a solid product, and you can self-host the controller. If Tailscale disappeared tomorrow, this is what I'd switch to. NetBird, a newer open-source WireGuard mesh that you can fully self-host, control plane and all. Cloudflare Tunnel. This is great for putting a public website on the internet without port forwarding, but your traffic flows through Cloudflare. That's fine for a blog that you want the world to see. It's not what I want for my security cameras. And now, the elephant in the room. And some of you are already typing it. Dad, isn't Tailscale's coordination server someone else's server? Yes. Look at you, paying attention. Your data doesn't flow through it, and the tunnels are end-to-end encrypted between your devices. What Tailscale holds is the directory, your account, your device list, your public keys, and for me, that's a trade I'm comfortable making for how well this thing works. But if you're not, and I love that for you, there's Headscale. Headscale is an open-source, self-hosted implementation of the Tailscale coordination server. The official Tailscale apps on your phone and laptop can point at your server instead of Tailscale's. It's the full someone else's serverification of the whole stack. It does want an always-on box with a public address, and that usually means a VPS. That's a bigger project. I'll probably be covering Headscale in my future VPS videos, so comment if you want to see that. If you've been following along, you've already seen Tailscale sneak into almost everything. In the Reolink NVR video, I told you that you could disable the UID P2P feature so your footage stops being brokered through Reolink's cloud, and to use Tailscale for remote viewing instead. A few of you asked what that actually looks like. This video is me paying that debt. My Nextcloud box syncs Mom the Creative's photos and videos from anywhere, and the server is never exposed to the public internet. The Home Assistant app on my phone works from any parking lot in the world. I can SSH into every Raspberry Pi in the house from the road. And through all of it, my router has 0 forwarded ports. Nothing is listening on the open internet. As far as the outside world can tell, my house is boring. However, it probably won't surprise you to hear that my house is not boring. So, what is a subnet router and why do you want one? The basic Tailscale recipe is to install the client on every device, and that works great, right up until it doesn't. That's because some devices can't run Tailscale. The Reolink NVR is a closed appliance, embedded firmware, no shell, nowhere to install anything. Your printer isn't running Tailscale, neither is your smart TV, EV charger, or the old NAS in the closet. And some of you have 30 plus devices on your network, and installing and managing 30 clients sounds like a part-time job. Here's where the subnet router comes in. A subnet router is one device on your home network that runs Tailscale and advertises your entire LAN to your tailnet. It raises its hand and says, anything addressed to 192.168.1.whatever, I'll pass it along. Think of your tailnet as the family group chat. Most of the family has smartphones. The subnet router is the aunt with the landline who relays messages to Nana. Except, in this metaphor, Grandma is your NVR who is never, ever, ever installing an app. Picture it. You're on a beach, far from home. You open the Reolink app on your phone, which is pointed at the NVR's local IP address. Tailscale sees that address belongs to the subnet your little box at home is advertising, encrypts the traffic straight to your house, and the subnet router hands it to the NVR. The NVR has no idea anything fancy has happened. As far as it can tell, you're sitting on the couch. And here's why you want one. It covers devices that can't run Tailscale. This is the missing piece for the Reolink remote viewing setup and for printers, NASs, and every other closed box in your house. One install covers the whole network. Every IP on your LAN becomes reachable through a single always-on device, even devices that recently joined your network. And it's family-proof. Put the Tailscale app on mom's laptop and she can reach the NVR and the printer from anywhere without learning what a subnet is. And a quick mention, Tailscale also supports making any Tailscale node an exit node, which routes all of a device's internet traffic through your home connection. Handy for making sketchy hotel Wi-Fi act like your house. You know, like a normal VPN. It's a different job and a different video. Let me know in the comments if you want to see that. So what can be a subnet router? Almost anything that's always on. Raspberry Pi, all the way down to a Pi 02W, a NAS, a mini PC, a home server, or a Windows PC that never sleeps. Today I'm showing you the two builds you've been asking for, the Pi and the Windows box. Build 1 is the Raspberry Pi subnet router. You'll need any Raspberry Pi running Raspberry Pi OS. And while the workload is so light that a Pi 02W is plenty, you'll probably want to opt for a Raspberry Pi that has Ethernet. That's because the traffic, when going through the subnet router, is bound by the speed of the interface. In this case, as in many others, Wi-Fi is not your friend. The good news is that a 1GB Raspberry Pi 5 is $45 over at Micro Center. Other good news is that you can also use the Raspberry Pi 3 or 4 from the Pi-hole WireGuard Home or Nextcloud videos and just load this on it too. Assuming you already have a loaded Raspberry Pi, this will take you a couple minutes. If you have to load one, starting with the operating system, follow the Raspberry Pi imager instructions from the Pi-hole video linked in the description below. You'll be using SSH. If you're not familiar with how you use SSH, I explain it pretty well in the Pi-hole video. Every command I'm about to run is on the worksheet in Part A, so don't do the whole pause and squint thing. Watch now, copy and paste later. So it's the 0th thing first. Give the Pi a DHCP reservation on your router or set a static IP so its address never changes. Same drill as the Pi-hole and WireGuard Home videos. A subnet router that wanders around your network is a bad time. You're going to install Tailscale. Then you're going to turn on IP forwarding. Out of the box, Linux refuses to pass traffic from one network interface to another, which is exactly the job we're hiring the Pi to do. So we'll flip the switch, permanently. Then you're going to find your subnet. Most home networks are 192.168.0.0/24 or 192.168.1.0/24. If you're not sure, run this and look at the address on your Ethernet or Wi-Fi interface. If the Pi's address is 192.168.1.47, your subnet is 192.168.1.0/24. There's a blank on the worksheet, and you're going to write this in it. You'll use it in the next step and again in the Windows build. Bring Tailscale up and advertise your subnet, substituting your subnet, obviously. The first time it prints a login URL, open it, sign it, done. The Pi is on your tailnet. Then you're going to approve the route. Tailscale won't route a subnet just because a device asked. In the admin console at login.tailscale.com, go to the Machines page, and your Pi will have a subnets badge waiting for approval. Click the three-dot menu, then Edit Route Settings, and toggle your subnet to on. Advertise the device, approve in the console. It's a two-man rule, like with ICBM launches, but for your printer. While you're in that menu, you'll also click Disable Key Expiration for the machine. Otherwise, in a few months, the Pi's login will expire, your cameras will go down while you're on vacation, and you get to re-authenticate a headless Pi from a beach chair. Ask me how I know. Then you will accept routes on your other devices. Phones, Windows, and Mac clients accept subnet routes automatically. However, any other Linux devices on your tailnet will need to be told. Finally, you're going to test it. Take your phone, turn off Wi-Fi. So you're on cellular. Make sure Tailscale is connected and open the NVR's local IP in the Reolink app or in a browser, or connect to whatever other device that you want it to connect to. If the login page loads over cellular, congratulations. You're holding your entire home network in your hand and nobody else on the internet can see any of it. That's the whole build. It sips a few watts. Set it and forget it. Build 2 is the Windows subnet router. Why would you use Windows for this? One reason: you already have a PC that never turns off. An office desktop, a media server, the household everything machine. If it's on 24/7 anyway, you can skip buying hardware and have this running in about 5 minutes. Commands are in part B of the worksheet. You'll start with installing Tailscale for Windows. You'll grab it from tailscale.com/download, install, sign it with the same account as everything else. Then you'll advertise your subnet. You'll open PowerShell as administrator. Right-click on the Start button, open the terminal as admin, and then run the same command as the pi minus the sudo. Then you'll turn on IP forwarding. Windows, like Linux, doesn't forward traffic between interfaces until and unless you tell it to. One registry value flips it on. The most annoying part is that you have to reboot. The registry change doesn't take effect until you do. The worksheet also has a per interface PowerShell method if you'd rather not touch the registry or reboot. It's harder and I wouldn't do it. Then you're going to approve the route. This is the exact same as with the Raspberry Pi. You'll open the Tailscale admin console, go to the machines page, 3-dot menu, edit route settings, toggle the subnet on, and you'll disable the key expiration on this machine while you're there. Then you're going to enable unattended mode. This one is easy to miss, but it matters. By default, Tailscale on Windows only runs when you're logged in. Click the Tailscale icon in the system tray and turn on Run Unattended. Now it starts with the machine and keeps running at the login screen, so a 3 a.m. Windows Update reboot doesn't take your remote access down with it. Next, you're never going to let your computer sleep. A sleeping subnet router routes exactly nothing. Settings, System, Power. Set sleep to never when plugged in, or one command in the same admin PowerShell on the worksheet. Then you're going to test it, and this is exactly like step A7 on the worksheet. Phone on cellular, Tailscale on, open a local IP across the internet. About the Windows option, I just want to mention that a desktop PC idles anywhere between 30 and 150 watts. The Pi does its job on about 3. If that PC is on around the clock anyway, fine. The subnet routing is free. But if your PC would normally go to sleep or hibernate when not in use, I don't think it makes sense to be out of power save 24/7 just to do this. You can get a 1GB Raspberry Pi 5 at Micro Center for $45, plus Windows also reboots for updates on its own schedule. My advice: run it on your HomeLab server if you have one. If not, Windows is fine if it's already always on. Otherwise, get a Raspberry Pi. This video feels so short compared to the other ones I've been doing lately, and it's because Tailscale is easy. It gives you a private encrypted network between your devices with no security exposure, no open ports, and no monthly fee. A subnet router extends that network to every device in your house, including the ones like the Reolink NVR that can't run Tailscale natively. And you can build one in minutes on a Raspberry Pi or on the Windows PC you already leave running. If you came here from the NVR video, this was your missing puzzle piece. Go finish the drill. UID and P2P off, static IP or DHCP reservation on the NVR, subnet router up, and add the NVR by its local IP in the app. Local, private, and yours, even from 1,000 miles away. And for the burn it all down self-hosters, comment if you want to see Headscale in the upcoming VPS series. Subscribe if you don't want to miss it. Tell me in the comments what made you want a subnet router and the weirdest device on your network that you can now reach from the road. Somebody out there is checking a fish tank, and I want to hear about it. If you found this useful, hit like, subscribe, and share this with the friend who still uses remote desktop port forwarded to the open internet or uses Google's remote access. You know the one. If you want to support my work, please hype the video and consider becoming a member. I'm not a big deal, so it's pretty cheap. If you really like what I'm doing, there are expensive tiers too. And here's where I would show you new members, but I haven't had any new ones in the last couple weeks. Thanks, and have a great day that's completely protected with WireGuard tunnels.